Hello student, welcome to video lecture series in Engineering Mathematics 1. In today's session, I would like to teach you the application of Jacobian, which is partial derivative. So by using Jacobian, we can find the partial derivative of function of two variable or three variables. Now here, consider the four variables u, v, x and y related by implicit functions related by implicit function, that is f1 equal to uv xy equal to 0 and f2 equal to uv xy is equal to 0. Now these functions expresses uv as a function of dependent variable x and y. To find the partial derivatives of w by w x, w by w y, w by w x and w by w y. Now how to write the formula for partial derivative of u with respect to x? The formula is minus Jacobian of f1 f2 with respect to uv. In the denominator, write Jacobian of f1 f2 with respect to uv. So in numerator, Jacobian of f1 f2 replace u by x. In the denominator, just replace u by x. So x into v. So first you write denominator Jacobian of f1 f2 with respect to uv. Now in the numerator, just replace u by x. So this is the formula for partial derivative of u with respect to x. Similarly, partial derivative of v with respect to y, if you want to calculate partial derivative of u with respect to y, then it is minus, first write denominator f1 f2 with respect to uv, do not change the order, and the numerator Jacobian of f1 f2 with respect to, just replace v by y. You as it is, replace v by y. Also, if you want to calculate partial derivative of v with respect to y, what is the formula? Just first write denominator Jacobian of f1 f2 with respect to uv, and in the numerator Jacobian of f1 f2 with respect to u. Now here just replace v by x. Solve the numerator and denominator and substitute the value. We get the partial derivative of v with respect to y. Similarly, we can write partial derivative of v u with respect to y also. You write the formula for partial derivative of u with respect to y. Also, for 6 variables, similarly for 6 variable, we can also write the formula for 6 variables. Just 1 second. Similarly for 6 variables u, v, w, x, y and z are connected by implicit functions. That is f1 u, v, w x, y, z is equal to 0. F2 is what? u, v, w, x, y, z equal to 0, and third function is what? F3 u, v, w, x, y, and z equal to 0. Now to find partial derivatives, u with respect to x, u with respect to y, v with respect to x, v with respect to y, v with respect to z, w with respect to x, w with respect to y, w with respect to z. How to find this? If I want to calculate w with respect to z, I want w with respect to x. So what is the formula? Minus first right denominator f1, f2, f3 u, v, w, Jacobian of f1, f2, f3 with respect to u, v, w. Now just replace in the numerator Jacobian of f1, f2, f3, replace w by x, u, v, x. Do not change the order is u, v, w, only replace w by x. Now you write v with respect to z, try for this u. So what is formula? Minus first right denominator Jacobian of f1, f2, f3 with respect to u, v, w, and the in the numerator Jacobian of f1, f2, f3 with respect to u, v, z. Now let us take one example depending on this topic. So example is, if x is equal to u square minus v square and y is equal to uv, then find partial derivative of u with respect to x. Find partial derivative of u with respect to x. Here I want partial derivative of u with respect to variable x. So for that, now I will write the implicit function f1 is equal to x minus u square plus v square equal to 0, and second function f2 is what? Y minus uv equal to 0. So here f1 and f2 are implicit function. Therefore, by using the partial derivative of implicit function, by using partial derivative of implicit function, क्या लिखा था हमने फॉर्मूला? Partial derivative of u with respect to x is equal to minus first right denominator Jacobian of f1, f2 with respect to uv, and the numerator Jacobian of f1, f2 with respect to, just replace u by x, x into v. So this is a minus numerator and denominator. Now separately find numerator and denominator. Separately calculate numerator and denominator. So numerator is, what is numerator? Jacobian of f1, f2 with respect to x into v, and which is equal to determinant f1 with respect to x, partial derivative of f1 with respect to v, second row partial derivative of f2 with respect to x, f2 with respect to v, then differentiate f1 with respect to x. What is differentiation of f1 with respect to x? 1. f1 with respect to v is a 2v, f2 with respect to x 0, and f2 with respect to v is minus u minus 0, and that value is equal to minus u. Similarly, denominator is Jacobian of f1 f2 with respect to uv, and this is equal to partial derivative of f1 with respect to u, f1 with respect to v, f2 with respect to u, f2 with respect to v, and it is equal to f1 with respect to v is what? What is f1? Is a minus 2u. f1 with respect to v is 2v. f2 with respect to u is minus v, and f2 with respect to v is minus v. So solving this determinant, we get 2 times u square plus v square, and then finally substitute this value in 1 for the partial derivative. Substitute this value in 1 for the partial derivatives. And therefore, partial derivative of u with respect to x is equal to partial derivative of u with respect to x is equal to minus. What is our numerator? Numerator is minus u. And what is denominator? Is 2 times u square plus v square. Minus minus become plus. So final answer is 2 times u square plus v square. Next example. If u square plus x into v square is equal to x plus y, and v square plus y into u square is equal to x minus y, then find partial derivative of v with respect to x. Now here the implicit functions are u square plus xv square minus x minus y equal to 0, and f2 is v square plus yu square minus x plus y is equal to 0. Okay, if next example, u square plus xv square equal to x plus y, and v square plus y square equal to x minus y, then find partial derivative of v with respect to y. Now implicit functions are here. f1 is u square plus xv square minus x minus y equal to 0, and f2 equal to v square plus y square minus x plus y is equal to 0. Now write the formula for partial derivative of v with respect to y. So it is minus Jacobian of f1 f2 with respect to what? uv, and the numerator Jacobian of f1 f2 with respect to, just replace v by y. Just replace v by y. Now separately find numerator and denominator. So numerator is what? Jacobian of f1 f2 with respect to u y. How to calculate f1 f2 with respect to u y? So first row is what? Derivative of f1 with respect to u y. f1 with respect to u, f1 with respect to y, f2 with respect to u, f2 with respect to y. Now differentiate this. Differentiation of f1 with respect to u is what? 2u. f1 with respect to y is minus 1. f2 with respect to u is 2 times uy, and f2 with respect to y is u square plus 1. Solve this determinant. Solving the determinant, product of these two is equal to, it is a 2 times u square plus 1 minus y become plus 2 times uy, and that is 2 times u cube plus 2u plus 2 times uy. Also find the denominator. What is the denominator? f1 f2 with respect to uv. Denominator is Jacobian of f1 f2 with respect to uv, and this is equal to f1 f2, it is actually f1 with respect to u, f1 with respect to v, f2 with respect to u, and f2 with respect to v. Okay, but what is f1? f1 equal to u square plus xv square minus x minus y equal to 0. So what is f1 with respect to v? Is it 2u? f1 with respect to v is equal to 2 times xv. f2 with respect to u is equal to 2 times uy, and f2 with respect to v is 2 times v. So solving this, 4uv minus 4 times xvy. ये कैसे निकालना है आपको पता है. f1 and f2 आर गिवन टू. व्हाट इज f1 f2? जस्ट यहाँ पर लिखा था मैंने, f1 and f2. डिफरेंशिएट f1 and f2 with respect to u, and this is your determinant. Solving the determinant, take product of this, 4uv minus 4 into xuvy. Now substitute all values in 1. Put all values in 1. Therefore del v by del y is equal to, del v by del y is equal to, substitute all value, it is a u square plus 1 plus y, and 2 times uv v minus xy. ये सब्स्टिट्यूट करो और सिंप्लीफाई करने के बाद यू विल गेट द आंसर. ये मैंने डायरेक्ट लिखा है, आपको सिंप्लीफाई करके लिखना है. थैंक यू वेरी मच.